Okay, so what you've seen so far is an approximations. That is the one theme that we will always return to over and over again. Okay, so that's the end of the chapter 1. So we start with the chapter 2, this is derivative. Okay, so if I back to this one. All right. Okay. Again, this is a problem of approximations. The thing is, let's see. When you have something like you're traveling from Jakarta to Bandung in say 2 hours and a half. 2 hours and a half driving through, say, or just say 3 hours. Okay, so it makes the computation easier. 3 hours for a distance about 150 kilometers. Okay. So then what can you say is that the velocity or the speed is about 150 divided by 3. So 50 kilometers per hour. Okay. So then let's see about speed. So traveling Jakarta to Bandung, kilometer in 3 hours. So the speed would be 3 hours divided by 3, that's 3 hours, kilometer an hour. Okay, so that's speed. The thing is that when you talk about the thing that you see at the speedometer, how is the speed correspond to we see in speedometer. Okay. Does this tells you that the speed is always 50? Not at all. Sometimes you go below 50, sometimes you go beyond 50, right? So this is what we call make a difference. This is what we call a average velocity, average speed, velocity. And the thing that we see in speedometer is that what we call instantaneous velocity. Okay. So the thing here in computing instantaneous velocity is rather strange. How to compute? Let's see. The thing is average speed that's easy. That's easy. Distance and over the, say, what I call is the durations, the travel time. Okay, and distance 150, duration 3 hours, then you have 150 over 3. Okay, all right. The thing with instantaneous is rather strange here. In instantaneous, well, the thing with the instant is if you're traveling, instant means that there's an instant t equals 0. There's no no difference in time. So instantaneous in an instant, there is no distance traveled, right? In instant mean no time. So no time means delta t equals 0. What is delta t? Delta t is time difference. No time difference. If there's no time difference, then no distance traveled. Okay. So in instantaneous speed, you have distance equals 0. Duration also 0. Okay. So in instantaneous speed, it's actually 0 over 0. So you compute nothing. All right. You see what I mean here? That the notion of instantaneous speed, if you define as speed over durations, that's 0 over 0. You see the reason why it's 0 over 0? Hello.
Yep.
Yeah. Okay, you see this is 0 over 0. Then it's kind of a contradictory thing. That's why we need to find out, well, can we somehow, if we cannot get the exact value, can we do some approximations? Can, can we do some approximations? Okay. So what's our kind of approximations? Well, we say that, okay, let's do average thing. Let's do averaging, but make the duration shorter and shorter. So compute average speed, but with durations shorter and shorter. Okay. So, right. So average speed is delta, say this is distance, right? Divides by delta t. Okay, so this is distance. This is durations. Distance is difference in positions. This is time difference. Okay. So what we compute is now compute this one. Delta x over delta t. And then make delta t smaller and smaller. Okay, so that's the idea of approximations. This is our approximations. Because there's no way you can compute 0 over 0. But with the approximations, we hope to get something. Okay. All right. but about what the computations out to some other scenario. Okay. Okay. The thing here is that how do you compute uh, a tangent line? Equation for tangent line at a point of a graph. Okay, so that's the equations. Okay, so for example, you have this one. Okay. So for example, at this point. All right, so the tangent line, that should be something that looks like this one. Okay, so what's the equation for this line? Okay. This tangent line. Okay. From chapter 0 and from high school, you know that to draw a line or to find equation for line, you need 2 points. Or computing equation of a line. Okay, so if you have two points, so say this is x1, y1, x2, y2. Okay, so what you compute is delta y over delta x. That's the slope. Okay. This is slope of a, say this one and this one, of a what I call the secant line, not a tangent. Okay. So in tangent line, basically, is determined by only one point. Okay. There is no second point to determine the equations. There is no second point to compute the equations. Okay, so that's a problem. So you only have only one point. It's like one instant in the here in the instantaneous speed. Okay, while average speed means difference over position over difference over time. So again, you have two position, two times. Okay. Okay, for secant line, you have 2 points. So difference in y, difference in x. Okay, while in tangent line, it's only determined by 1 point. Okay, f of a. There's no second point. All right. So again, do the approximations. Okay. So how you do the approximations is by something like this. Okay. So we compute this one. Let's compute this first secant line. Let's take Say this is our A. Just take the x1 here. So we take a secant line. Okay, let's move x2 here. So take equation of the line between this one. Okay. And let's move again to x3. There. And then keep going closer to this. And eventually, well, not eventually, you get something like getting close to this line. Okay, so what's the approximations? I would say strategy of approximations is take a secant line, secant lines actually, okay, between a f of a and x, say k. Okay, then you shift okay, so that's the should be the idea. Okay, so how we do this one? Let's compute one example. Okay, let's just do some easy thing. Secant square. That's just the easiest thing. So 1. We need to compute this tangent line. This tangent line. Compute the equations. Okay, so what we do here is that take another point at the graph. At the graph, say this one. To the left or to the right doesn't matter. And then compute the equations for secant line. Okay, so this is a secant line. Let's see. Okay. So this is the slope for the secant line is this delta y over delta x. All right. So difference is in this. So difference between 1 and f of x 1. Okay. And difference in x is 1 minus x 1. Okay. And then we compute this one and move this x1 closer to 1. Okay. Repeat these computations. Repeat as x1 gets close to 1. Okay. So let's do the computations. Let's formulate this one. Okay, so what we compute here is that okay, sorry, what we compute here is that this one. Okay, as x1 goes to 1, take the limit. Okay, now we have the tools to compute this thing. All right, so let's compute this. This is 1 minus x squared. This is 1 minus x. So this is limit x goes to 1. All right, so that's easy. What's the limit? How to compute this limit? What kind of trick you use to compute this
Factorize
limit?
the 1
Okay.
minus.
Factorize. So this. And you can cancel this. So you have this limit 1 plus x, right? Then is 2. Okay. So this is what we call the slope for tangent line. For tangent line of here. So that's the slope for this one. Okay, so that's a approximations. So the tangent line is defined by, that's a tangent, sorry, that's a line at going through this point with the slope coming from this limit. Okay, this limit is called derivative. At the same token, what we say about what is instantaneous velocity? Well, instantaneous velocity is actually average speed as the time lapse is the delta t, gets smaller and goes to 0. Okay, so instantaneous velocity and slope of a tangent line is both an approximations. So that's the conclusions that we write down. Both velocity and slope of tangent line are approximations of, well, if instantaneous velocity is this average speed, slope of tangent line is slope of secant line. As what? As time lapse goes to 0, right? And secant lines as what we call delta x. Yeah. Okay. So both are approximations. Right, so this is the idea of approximations. All right, I will stop here. And let me think about, no, let's just do this tomorrow. Let's continue tomorrow. So then you'll have a problem sessions later at 2. finish up the material for the problem set 2. Okay, questions?
For the problem session, we still use the module 1, yes, sir.
Yes, finish
Okay,
module
thank
1.
you.
Okay, if not, then I will stop the record. Record.